So looking at number 10, did you have an idea of what would be a good u for number 10?
No.
I like x to the 1/2. I think that's a good pick. Because du then, 1/2 x to the negative 1/2 dx. And then if we kind of clean that up a little bit or rewrite it, that's a square root of x in the bottom, which is what we have over here. So that's a great pick. Although you have to be careful. That means you want this to be u, but you don't want the bottom to be u. You want the bottom, or with a 2 in there, that is now du. So the top square root of x becomes u. The square root of x in the denominator, with a little help from the 2's, becomes du. And then that's an easy integration, but remember, don't forget to switch your limits. And the limits look weird, as they are, pi squared and pi squared over 4. But when you evaluate them, the square root of pi squared would just be pi. So that's good news. That's sort of back to normal. And if we square root pi squared over 4, that's pi over 2. So that's sort of back to normal. So now we got a much easier integral to work with. So the antiderivative of sine is cosine, but is it positive or negative cosine?
Positive. What?
The antiderivative of sine.
Oh.
Right? The derivative of cosine is negative sine, so I need a negative on this. And maybe you can just put the negative completely out front, the negative 2 completely out front, and then do top limit minus bottom limit. That is a safe stop, but multiple choice test is going to clean that up a little bit. Cosine of pi is negative 1. Cosine of pi over 2 is 0. Negative 2 times negative 1 is a positive 2. So again, safe stop it if you like, if you have the option or the ability to. But on a multiple choice test, they're going to simplify that. Other questions?
5. I was
Did you have an idea for what u should be? What do you?
got to like
What did you pick for u?
x squared minus 3.
Okay, I like that. Because du is 2x. Again, it's this game of picking u so that du shows up, but you don't know what du is until you pick u. So you have to kind of think ahead. Well, if u is this, then du is that. That works. Okay, so far so good. 2x isn't there, but we can make the 2x be there with a 2 and a 1/2, so that's not too bad. So 1/2 integral, leave the limits alone for now, and I'm going to rewrite that denominator as u to the negative 2. So I'm much more likely to integrate that correctly as u to the negative 2 than if it just said 1 over u squared. Okay, increase the power by, whoops, let's do the limits. I mean, I guess you don't have to do the limits. You could integrate and then fix the limits. It doesn't matter. But if I want to make this look right, I need to do the limits. So u of 3, let's see, that would be 9 minus 3 is 6. And u2, made a u2 joke yesterday in one of the classes, proud of myself. U of 2, 4 minus 3 is 1. So we found U2, but that's not the end of the problem. We still haven't found what I'm looking for. That's the U2 joke. Thanks. Thank you. Yeah. Alright, so now we've got it converted completely to U stuff from X stuff. So we changed it from this awful integration to hopefully an easier integration. And we had to pay a little bit of price along the way, but now we got something we can work with. Increase the power by 1, divide by the new power. 1 to 6. Let's see, 1/2 still out front. So I'm going to put negative 1/2 out front and rewrite that as 1 over U from 1 to 6. So that's negative 1/2 times plug in the top one minus plug in the bottom one. Again, safe stop is fine. This one you could mess with a little bit. 1/6 minus 1 is negative 5/6. The negatives cancel and you'd end up with 5/12. Safe stop versus multiple choice.
So why don't we turn U back into what we substituted for and then plug in the
That is a fabulous question. The question was, why don't we, somewhere in here, after we integrate, because we, right here, I guess, put the X stuff back in. Here's the answer to that, is you can do that. That's a different way to do it, is you get to here, you're like, well, I want to work this as an X problem. So you put the X stuff back in, so you'd have 1 over X squared minus 3. What else would you have to do? Or maybe not have to do. Well, yeah, so you have to change the endpoints, or you might say just keep them what they were. So they were 2 and 3. So if you want to do that method, you can, and it saves you from changing the endpoints. But the trade-off is you have to change the U stuff back to X stuff. And the reason I taught it with switching everything to U is because AP test usually has a couple questions where they word it and rig it in such a way to basically test that you know to change the endpoints. Like your answer choices, the problem stops right here, and so you have to know to be able to change those endpoints. But it's a great question, and I used to teach it both ways, but then I felt like it got confusing teaching it both ways because people would go, use half of one method and half of the other and miss the problem. So it's a good question, and the answer is you can work it that way if you like.
Where did the squared on the outside go?
Outside go. Like this squared?
Yes.
So that 2 is in the bottom. So that's what made this a U to the negative 2.
Okay.
Good questions. All right, let's pause there, stop there.